All right, so let's do our second set of notes, which is the for 9.5 on global climate change. Okay, and so we have the same learning objectives, and we're now going to talk about the impact of global climate change on marine ecosystems. So, Um, essentially, what is happening is that we're finding that the range of the marine ecosystems is actually being altered, it's changing, and some new marine habitats will form because of the sea level flooding along the coastline. And it'll turn those areas that at one point were terrestrial now into marine or aquatic ecosystems. Some areas of the ocean will actually change as well because now it'll be too deep to receive sunlight, and the photic zone will shift further from the ocean floor. Also, there are going to be some altered ranges for organisms. So, because warm water, we've talked about this before, but it holds less oxygen than cooler water. um, there are fish populations that have a range of tolerance for the amount of oxygen that's in the water. And so either those populations will decline as more oxygen leaves the water, or they will migrate to cooler regions that contain more oxygenated water. And so that is one of those impacts on ecological impacts of global climate change. There's also going to be an impact on, or there currently is an impact on ocean circulation as the temperatures are rising. That we're actually seeing a suppression of thermohaline circulation, which is that global ocean current that redistributes heat from the equator. It also redistributes salt and nutrients by mixing all of the world's ocean waters together. And that could actually slow or even stop altogether, which is a real problem. If that salt and those nutrients and that water is not circulating properly, this is sort of what happens now, where we've got regions where cold water is going to be moving, the current is pushing the cold water along, mixing up the ocean, and then also areas where the warm water is being pushed in currents. And so we're going to see some real problems with the nutrients essentially in those areas. So ice melts from Greenland, especially cold, and that's causing this cold freshwater buildup in the North Atlantic. So we're getting a much more cold water there than we've had in the past. And when this ice is melting from land, it's actually fresh water. So fresh water is less dense than salt, so it actually prevents that water from sinking. And then it slows the warmer Gulf Stream waters. And essentially, what impact that has over land is that it cools Europe and it slows that global thermohaline circulation. So that's a real problem. And so that's one thing that Europe is experiencing right now. There's also unequal global warming. So this graphic kind of shows you who is being impacted most by global warming, what areas of the world. So the Arctic region, the North Pole, is especially susceptible to climate change because all of that ice that is there is going to be melting. And because there's more land in the Arctic and less water to absorb the heat. So that is a real problem there. And then essentially, with these Arctic regions, the melting sea ice means that there's going to be more exposed ocean water, and this absorbs more sunlight than ice and snow. So it's going to lead to even more ice melting. So that's just another positive feedback loop, is that that melting sea ice is just going to get worse and worse. It's going to get further and further away from normal. Again, that's why it's a positive loop. We're also going to see that there's going to be a distribution of tropical heat to the poles because of the thermohaline circulation. It's going to cause a general warming of the oceans around the polar regions. And we already talked about this, but we'll see that melting of permafrost, which is, again, another positive feedback loop. And so this air pollution that's going to be, um, we're going to experience because of that melting permafrost. We'll add soot and other particulate matters to the atmosphere, and that's going to be distributed to the poles because of atmospheric circulation. So, darker soot or darker particulate matter covers the ice and it absorbs even more heat because of the lower albedo. So, that's a real problem. And so, what does this mean for the polar regions? Because we think, well, there's not a lot of people that live there. So, what's the big deal? Well, this Arctic sea ice loss is going to actually cause a pretty tremendous habitat loss. And because of that, it's going to really impact the food web of our oceans. So, seals in particular use it for resting and for finding holes for breathing. Losing that sea ice is going to be a problem for that. It's also there's algae that can grow on the ice, and that's kind of the major producer of the Arctic food web. So we're going to lose that, which is going to cause an entire food web collapse if the producers in the food web are not there any longer. The polar bears actually use sea ice to hunt. So they hunt seals at basically the breathing holes that the seals use. They'll actually sit there and wait for seals to actually come through the ice at the breathing holes. So they get pretty skilled at breathing hole hunting. But then you can see this entire food chain that we don't really think about is now going to become impacted. All right, so that is it for 9.6. And our next section, or I'm sorry, that is it for 9.5. And our next section is going to be 9.6 ocean warming. And so I'll see you guys next time.